In this video, I will teach you how to evaluate inverse trig functions such as these. Throughout this video, I will be assuming that you have memorized your basic trig function facts. So if you have not memorized these 9 facts, pause the video and memorize them right now. But first I need to explain to you what an inverse trig function is. Up until now, you've done things like this. If I ask you what is the sine of pi over 6, you could tell me. You would say, that's 1/2. And maybe you got that off the chart, all right, that you've memorized. Sine of pi over 6 is 1/2. Okay, so an inverse trig function is the opposite. So I would say the inverse sine of 1/2 is what? So what I always say is an inverse trig function is an angle. We're looking for an angle. What angle is it? It's the angle whose sine is 1/2. In other words, in your mind, you should be thinking this. I'm going to put this sort of like a thought bubble. In your mind, you should be thinking the sine of what angle is equal to 1/2. That's what you're thinking. Okay, well, we just saw the sine of pi over 6 is 1/2. So the answer would be pi over 6. Now there's some restrictions that we're going to talk about in a minute, but for now, that's the basic idea. So an inverse trig function is an angle. It's the angle whose sine is this thing inside. Okay, so let's take a closer look at problem number 1. When you see the inverse cotangent of 0, that is asking you the following question. You should be thinking the cotangent of what angle is equal to 0. So theta, if I can find theta, that's going to be the answer to the question. The cotangent of what angle is 0. Now, remember that cotangent is the reciprocal of tangent. So you know how tangent is y over x? Well, cotangent is x over y. So we need x over y to equal 0. So the question is, what angle is it where that occurs? So let's draw a little diagram of the unit circle. All right, and the places that are likely to give us a 0 are the quadrantal angles. So let's take a special look at those. This is 1, 0. This is 0, 1, -1, 0, and 0, -1. Now, in each case, let's ask ourselves what x over y is. So right here, x over y, that would be 1 over 0. That's undefined. Okay? Right here, x over y, that's 0 over 1, that's going to be 0. All right, -1 over 0, that again is undefined. And 0 over -1, again, that is 0. So I want the angle where the cotangent is equal to 0. So I have two possibilities, pi over 2 and 3 pi over 2. Now here's where it gets a little bit tricky. We want the inverse trig function to be a function. So you can't have a function that has one input, 0, that gives you two different outputs, pi over 2 and 3 pi over 2. It needs to be one input that gives you one output. So we can't have two answers. So the way they solve that problem is to place restrictions on the inverse trig functions. And so you really have to memorize these restrictions. Okay, you need to memorize this chart. But right now we're talking about inverse cotangent. Inverse cotangent has this artificial restriction. It is only defined for the top half of the unit circle from 0 to pi. All right, of course, we're not going to include 0 or pi because it's undefined in those two places. Okay, so if I'm going to choose between which one of these is going to be the answer, I need to choose the one at the top because that's where inverse cotangent is defined. All right, so I have to choose this one because of the restrictions. So that's why the final answer is pi over 2. Okay, it's going to take some more practice before we get that craziness down. So take a look at problem number 2. Inverse cosine of 0. That means the cosine of what angle is equal to 0. Okay, so here's our diagram again. Now, remember that cosine is simply the x value. So where is the x value equal to 0? All right, well, hopefully you can understand that the x values, all right, we're talking about how far it is left and right. The x value will be 0 here and here. Okay, so again, I've got pi over 2 and 3 pi over 2. And if you want to be real specific, sure, this is the point 0, 1, but I'm only interested in the x value, which is 0. And this is the point 0, -1. Again, notice that the x value is 0. So again, we have our restrictions. So this time we're talking about the restriction on inverse cosine. And similar to inverse tangent, the inverse cosine is only defined on the top half of the circle from 0 to pi. So for that reason, we're going to pick the one at the top. So the answer is pi over 2 again. Okay, more practice. When you see this problem, the inverse sine of negative radical 2 over 2. First of all, I need you to understand that radical 2 over 2 is the same thing as 1 over radical 2. So if you learned it as 1 over radical 2, don't get confused. These are the same thing. So this problem is the same as the inverse sine of negative 1 over radical 2. And what you're asking yourself is the sine of what angle is equal to negative 1 over radical 2. Okay? Now, if you were just thinking, well, that's easy. The angle has to be pi over 4. Okay? Now, that's close. Pi over 4 is the reference angle. It's not the answer. Okay? And it is not the answer for two reasons. First of all, the sine of pi over 4 is positive 1 over radical 2, not negative. Okay? But let's think about it. Here is a... Okay, that's not a very good circle. Let me try that one more time. Man, no, it doesn't have to be perfect, but come on. Okay, I'm going to draw a diagram of pi over 4, since I definitely know the reference angle is pi over 4. So here are some pi over 4s. All right, these are the 4 angles that have a reference angle of pi over 4. The sine of any of these is going to give me some kind of 1 over radical 2. It's just that some of them are positive and some of them are negative. Remembering that sine is a y value, I will understand that sine is positive in these two quadrants, above the x-axis, and it is negative in these two quadrants. So we want the sine to be negative 1 over radical 2. Okay, so that means it's got to be one of these two down here at the bottom. So the only question is, which one of these two is it going to be? And it depends on the restrictions. All right, in fact, that's what the restrictions are for, so you don't have more than one answer. So you just have to memorize that inverse sine is only defined on the right-hand side of the circle. It'll help you remember that this is the restriction if you at least look for a zone where you'll get positive values and negative values. Sine is a y value, so it's positive up top, negative down below. So by taking this half of the circle, you're getting positives and negatives. If we did the top half of the circle like we did for cosine, well, all of this is positive. Oh, I'd only get positive values if I was doing the sine function. So that's why they did it this way. So right-hand side of the circle. Okay, so if I want a negative 1 that's on the right-hand side of the circle, that means this has to be the answer. All right, so what is that guy? If I went all the way around, that would be 8 pi over 4, so this must be 7 pi over 4. Wait, hold on. I made a mistake. This is not the answer. Skirt! Okay, 7 pi over 4 cannot be the answer. Well, don't mean to go that far. Okay, 7 pi over 4 cannot be the answer because, let me see if I can convince you why this does not actually fall within the restricted area. So, inverse sine is only defined for the top half of the unit circle. Okay, as I mentioned, the right-hand side of the unit circle. Okay, inverse sine is only defined between negative pi over 2 and positive pi over 2. Okay, so, in other words, inverse sine is only defined between here and here. Now, at first, I thought that this was going to be fine because you can see that it falls within this zone. And in fact, this terminal side is fine. Okay, this terminal side is what I want. The problem is calling it 7 pi over 4. Because if I call it 7 pi over 4, that means that I started here at the positive x-axis, and I went all the way around clockwise and back. And if I did that, I am leaving the restricted area, and I'm going outside into the undefined zone, and then I'm coming back in. That's not allowed. This angle is beyond the limits. It's too big. So we can't do it that way. So I need another way. Okay, so is there a way that I could get from the positive x-axis to the terminal side that I want without leaving the restricted area? Sure, I can just go the other way. I can go clockwise. If I go that way, I get to the same place without leaving the restricted area. But if I go that way, it's not going to be called 7 pi over 4. Okay, that angle that I've drawn is negative pi over 4. Okay, even though these are coterminal angles, all right, they have the same terminal side, the same ending spot, they are not the same. Okay, negative pi over 4 stays within the restricted area. 7 pi over 4 goes outside and then comes back. So this is what we have to put for the answer. Negative pi over 4, not 7 pi over 4. Okay, this looks very weird. I need you to understand that this is really the same thing as, okay, cosecant of negative 2 over radical 3. Okay, this looks very weird, but all they did was rationalize the denominator. If I have 2 over radical 3, and I want to rationalize the denominator, I would do that by multiplying by radical 3 in the top and the bottom. So that would give me 2 radical 3 over 3. That's where this is coming from. Okay, so we're more comfortable thinking of it this way, negative 2 over radical 3, without rationalizing. So that will help you understand what's happening. Okay, so you should be asking yourself the following question when you look at this. This should make you think, all right, the cosecant of what angle is equal to negative 2 over radical 3? Well, cosecant is the reciprocal of the sine function. All right, so this would be the same as asking yourself the sine of what angle is equal to negative radical 3 over 2. Okay, and let's start with the reference angle, because that's all you can really do. So the reference angle is going to be, all right, think of your chart. Ignore the negative sign for a second. Sine of what angle is radical 3 over 2? All right, I'm hoping you were thinking pi over 3 just now. All right, I'm thinking of the chart. The sine of pi over 3 is radical 3 over 2. Okay, so that tells me that pi over 3 is the reference angle. Now, to get the actual answer, I need to think just a little bit more. Since the reference angle is pi over 3's, I'm going to draw some pi over 3's real quick. All right, the sine of any of these 4 angles will be some kind of radical 3 over 2. It's just that these two will be positive radical 3 over 2, because sine is a y value, and y values are positive up there. These two will be negative. So, of course, I want the negative ones, okay, because I have negative radical 3 over 2. So that means I definitely want one of these. Now, which one is it going to be? Well, that comes down to the restrictions. Okay, inverse sine is only defined on the right-hand side of the unit circle. Okay, which means I need to pick the one on the right-hand side, which is this one. All right, so what is the final answer then? One angle that lands at this position is 5 pi over 3. So in the past, I probably would have just said, oh, so this is 5 pi over 3. But we have to be careful. Let's take another look at those restrictions again. Inverse cosecant. Okay, inverse cosecant is only defined on the right-hand side of the unit circle. Okay, so inverse cosecant is only allowed to be over here. Okay, so in fact, I'm going to put sort of a y-axis here. All right, I have to stay within this zone. I can't leave it, even temporarily. Even if I come back, I can't leave this. It's like a prison. I'm trapped over here. Okay, so the problem with 5 pi over 3 is that means I started from the x-axis and I went counterclockwise, and see how I'm leaving the restricted area to do this. Now I'm outside of the restricted area right now. And even though I come back into the restricted area, the fact that I had to go outside of the restricted area to get there, that's not allowed. That's not okay. Okay, so I cannot use the angle 5 pi over 3 because that goes beyond the restricted area. So I still want to have this as my terminal side, but I need to go the other way. I need to go clockwise and go straight there. That way I stay within the restricted area at all times. And in this direction, this angle I've just drawn is negative pi over 3. Okay? Now, even though that is a coterminal angle with 5 pi over 3, they are not the same. All right? So I have to say negative pi over 3, not 5 pi over 3. Okay, when you see this problem, the inverse sine of negative 1, you should be thinking the sine of what angle is equal to 1? All right, and sine is just a y value, so you should be thinking, where is the y value equal to 1? Okay, so the y value equals 1 only in one place, right there at the very top. So this is unambiguous. The answer has to be pi over 2. Okay, what about number 6? When you see this problem, you should be thinking the sine of what angle is equal to negative 1/2. Okay, what is the reference angle first of all? If you ignore the negative sign, the sine of what angle is 1/2? All right, that's pi over 6. I'm hoping you were thinking pi over 6 just then because of the chart. Sine of pi over 6 is 1/2. Okay, now that's just the reference angle though. So to get the real answer, the final answer, let us imagine the chart, a diagram of pi over 6's. Okay, so there's a bunch of pi over 6's. Now, these are the 4 angles that have a reference angle of pi over 6. All right, the ones like just above and below the x-axis. All right, so these 4 angles have a reference angle of pi over 6. Sine is a y value. So these two are positive and these two are negative. So we want a negative 1/2 answer. We want a negative answer. So that means it's going to be one of these two. All right, so the only question is which one is it? And that depends on the restrictions. All right, inverse sine is only defined on the right-hand side of the circle. So that means I'm going to choose this one. So what is the value of that? Please, please, please be careful. I almost called this 11 pi over 6. And that's what it would be if I started from the positive x-axis and went around, okay, counterclockwise, and I got here. So that would be 11 pi over 6. But that is illegal. All right, let me see if I can convince you of why. So remember the restrictions on inverse sine. Inverse sine is only defined for the right-hand side of the unit circle, from negative pi over 2 to positive pi over 2. Okay, so that means inverse sine is only defined from here to here. Okay, and just to make it more clear, I'm going to go ahead and drop this down along the y-axis. This is like a prison. All right, this is my universe. Nothing exists, as far as inverse sine goes, nothing exists outside of these boundaries. So, if I try to name the angle 11 pi over 6, that means I started from the positive x-axis and I went around and bam, I'm leaving the defined area. I'm in no man's land. I'm in the undefined area. This is not allowed. This is illegal. All right? Even though I eventually come back inside the restricted area, that's too late. I cannot choose an angle that leaves the defined zone. So I need to go another way. All right? So instead of going counterclockwise, I need to simply go clockwise, like this. Okay? Now, I end up at the same place, but going clockwise, I never leave the restricted area. So everything's okay. So, what is this called? What angle have I just drawn? That is negative pi over 6. So for your answer, you have to call it negative pi over 6. You cannot call it positive 11 pi over 6. Those are coterminal angles, but they are not the same. All right, for number 7, inverse secant of radical 2. You should be thinking, okay, the secant of what angle is equal to radical 2? Well, the secant is the reciprocal of the cosine function. So this would be the same as asking the cosine of what angle is equal to 1 over radical 2. Okay, now what is the reference angle? Because that's really what you're asking yourself first. So cosine of pi over 4 is 1 over radical 2. So that means that's the reference angle. It's not necessarily the final answer until you think about it and verify that it has the right sign and it meets the restrictions. So pi over 4, here is a diagram of pi over 4s. All 4 of these angles have a reference angle of pi over 4. All right, cosine is an x value on the unit circle, so that means these two are positive and these two will be negative. So I want a positive 1 over radical 2, so that means I want one of these. All right, but which one will it be? I consult my restrictions, and inverse cosine is only defined on the top half of the unit circle. So I need to pick the upper answer. So I'm going to pick this one, which actually does turn out to be pi over 4, but it won't always be the reference angle. But in this case, the final answer is in fact pi over 4. Okay, how about number 8? Inverse cotangent of radical 3. So you should be asking yourself, okay, the cotangent of what angle is equal to radical 3? Well, I'm more familiar with tangent, so I'm going to ask myself the tangent of what angle is equal to 1 over radical 3. So this is something that I have memorized. Okay, that is pi over 6. So the reference angle is pi over 6. Now, is that going to give me positive 1 over radical 3? Yes. Is pi over 6 in the defined area? So let's see, where is cotangent, inverse cotangent defined? Let's look at the restrictions. Okay, inverse cotangent is only defined for the top half of the circle. That includes the first quadrant, and that's where pi over 6 is. So the answer is going to be pi over 6. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.